In this video, I'm going to show you how to take a component vector and turn it into an angle magnitude vector. Okay. Now the first step, and this is the hardest step, okay, is to draw the vector. Okay. For some reason, this is like the most baffling step for some of my students, but I'm going to draw these guys tip to tail. I'm going to make them arrows. So first I'm going to go to the right, 5.10 meters, and I'm not going to measure this. I could do that. I could measure that and make that 5.10 centimeters or something, right? And then notice that this is negative, right? Okay, so the y one sprouts off of the tip of the x one. I always draw the x first and the y second, but you don't have to. And then this guy goes down, and I'm careful to make that one shorter than this one, okay? I'm not doing it to scale exactly, but the shorter component, make it noticeably shorter, okay? Now, this side is 5.10, this side is 1.7, okay? The vector is actually this guy right here, okay? The thing that goes from the beginning of the first one to the end of the last one. That's the vector. And these should meet tip to tip, but you know, there we have it, right? Okay. Now, the next thing to do, step 2, is to find the magnitude. Okay. Now, since these guys are components, they're always at right angles to each other, we can use the Pythagorean theorem. Okay. If you need it, it's that the hypotenuse squared equals the opposite squared plus the adjacent squared. Okay? So I'm going to find the magnitude. It's going to be the square root of 5.1 squared plus 1.7 squared. Okay? Now notice I'm not putting the minus sign in there. More about that yet in a moment here. Okay? Square root of 5.1 squared plus 1.7 squared. And I get 5.37. I'll say 5.38. Okay. Now, why didn't I put the minus sign in there? Well, just be very careful. Okay, if you type this into your TI calculators, it will give you a negative answer, and I believe that's incorrect. I believe negative 1.7 squared is actually a positive number. Okay, but they interpret it as the opposite of 1.7 squared. So if you want negative 1.7 squared, put it in parentheses in your TI calculators. Okay. Then it will interpret it correctly, because of course it's not going to override the parentheses, okay? Just be very careful. You know that the negative number squared is the same as the positive number squared, so you don't need to put them in there, okay? So anyway, so now we've got this. These are, by the way, meters. So that's our magnitude here is 5.38 meters, right? And now we just have to find an angle there, okay? So there, that angle there, that theta, okay, this is the adjacent side. This is the opposite side. Okay, and so the rule for that is that the angle there, and we're using SOHCAHTOA here, that angle is the inverse tan of opposite over adjacent. Okay, right, and this comes from TOA, which says that the tangent is the opposite over the adjacent. Right. Okay, so finally we use the TOA of SOHCAHTOA. Right. Okay, so that angle is going to be the inverse tangent of the opposite side, 1.7 over 5.10. Okay, so let's do that. Second tan of 1.7 divided by 5.1. And I get about 18.4 degrees. Now, common student question. Why did I pick that angle? Well, certainly I'm not going to pick that one angle. That's 90 degrees all the time, right? It doesn't matter. I just always pick that angle there because just to be consistent. I always pick the angle with the x-axis. You could find this angle. It's just going to be the complement. It's going to be 90 minus this one. All I ask is that when you draw a picture of a vector, that you draw the vector. The vector is an arrow, okay? So I know that you know it's down and to the right because this is to the right and down, okay? That you know some angle there, right? And that you know the magnitude of the vector. You just need to draw a picture of it. The direction is in the picture there. And notice here in English I said 4.4 degrees below the x-axis. This would be the x-axis, and there it is below that, right? So you could include descriptive language, but the very best thing is to draw it. This is the best thing, is this picture with the magnitude labeled, the angle labeled, as being whatever it is, okay? And it's always true that that any angle is the inverse tangent of the opposite side over the adjacent side in a right triangle. I'm going to do a bunch of examples. You should practice. The hardest thing I've found is that people just can't draw the vector. Okay, so practice at least that.